given this information, first of all, let's change all of these into fractions. So what can we change 80% as? 80% is 8 hundredths. Sorry, not 8 hundredths. 80 hundredths. Which can we reduce that? 80 hundredths would be 8 tenths, which is 4 fifths. Now, 0.20 is 20 hundredths, or 2 tenths, or what else? 1 fifth. Now, could we have changed all these to decimals or changed them all to percents? Yeah, you can put them in whatever terminology you want, but I'm going to deal with fractions right now. So you have probability of A, probability of B, and probability of C. 2 fifths, 4 fifths, and 1 fifth. How do we find the probability of A and C? Now, first of all, did I say if they're dependent or independent? Assume normally it's normally probabilities are independent. Sorry, most of them are dependent. Like one affects the other most of the time, but I didn't really say on this one. So let's just go with that they don't affect each other. Because, for instance, probability of A is what? 2 fifths. So do you understand this would be probability of A times probability of C, according to your notes? Do you understand and means multiply? And A, isn't A 2 fifths? And isn't C 1 fifth? So wouldn't you just simply multiply these two? And when you multiply these two, oopsie daisy. When you multiply these two, what do you get? 2 25ths. Now, could I change that to something different? Yeah, but let's just, are we okay so far? I could change that to percentages. That would be 80%, 8%. You could change that to a fraction, a decimal. Anyways, oh, by the way, the probability of two events. Number 2, we're probability of A or C, meaning one event has the characteristics of A or C. Or means what? Plus. And what does mutually exclusive mean? Do they overlap? Do the two characteristics overlap? No. So simply this is going to be probability of A, or means plus probability of C. So what's the probability of A? A is 2 fifths. And what was the probability of C? 1 fifth. And all we do is add these. That would be a probability of 2 plus 1 is 3. Keep the bottom. 3 fifths. So the probability of getting probability of A or C, you add the two. Now the last one, make sure you're careful with this. It's A or B, not A or C, so you got to kind of watch that carefully. But it's not mutually exclusive, meaning they affect each other, like the A or B overlap. So not mutually exclusive would be probability of A plus probability of B minus what? Minus the probability of A and B. It's a little bit more complicated. So the probability of A was 2 fifths. The probability of B was 4 fifths. Now right away, does that seem kind of stupid? I have a chance of 6 fifths. I have over 100% chance of it. That makes no sense. Do you see how the overlap doesn't make sense? There's a whole bunch of stuff that overlaps, so they can't really work to have a bigger than 1. Anywho, this one, the probability of A and B, don't you multiply these two? And means you're going to multiply. So if we calculate this, that will give me the probability of A or B, but two events overlapped. And a lot of times you know if overlap events happen is if this gets over 100. Anyways, the top would be 6/5 minus, this becomes 8 25ths. Now, some of you might not like fractions, but how do we subtract these two fractions? We have to get a common denominator. So what looks like a good common denominator?
25.
25. So can I multiply this by what?
5.
5 over 5. So I now have 30 25ths minus 8 25ths. That would be 22 25ths, which is about 88% chance of happening. Okay, which is pretty high.